Hello, and welcome back to episode 3 of the motion matching tutorial series. I'm Kalechi, Technical Product Manager here at Motorica, and today I'll be showing you how we can take the dataset that we created in the last episode via Motion Factory, bring it into Unreal Engine, and get our character up and running. The same character that you saw in part 1 that was just T-pose sliding around. And this is all done with the help of our import plugin. Now, our import plugin is a process to make the whole workflow easier because if you have a large dataset, it might take a long time to actually import the assets, retarget, set up your gameplay systems, and etc., all that kind of stuff. So what our plugin does is it allows you to select the folder that you downloaded from your email, bring it into Unreal, import the animations, retarget to your target skeleton, set up the post-search databases, and have all your assets ready to play, game ready to put into your system in just a few clicks. And this is all an automatic process. So you just click the button, go and grab a coffee, come back in 2 minutes, and your stuff's already set up, ready to go in the game. And I can show you how that works actually. So first, I'll just, we'll refresh our memory and look at the character we have again. So as we saw before, T-pose sliding around, different states. We've got strafing, we've got forwards, we've got walking, we've got sprinting, all these kind of stuff that we took into account when creating our data set, and we have the same speeds and things inside here. So in theory, our data set should drop right onto this character and look quite natural. But the first step is actually getting our data into the engine. So that's going to happen if we click this button here, which is the quick import setup button. We click this button, and then I'm going to select the folder that I downloaded from my email. So I got the zip file, extracted it to this folder, and here's the folder here. And you can see inside the folder, we have the exact same setup. So we have the same folder structure, same files, all this kind of stuff is exactly the same that we saw in Motion Factory, ready to go into our gameplay system. So we can click that, click select folder, and now we're going to be asked which folder we want to put the assets into once we finish the setup. So I'm going to create a new folder and call it tutorial dataset. So if we were to click import now, it would import all the animations onto the Motorica skeleton. And this is a version of the Motorica skeleton that comes packaged with the plugin. But the difference from the one that we get on the web app is it's Z-up. And this is because some of the nodes in the animation warping plugin don't really work if the skeleton isn't Z-up. So we have a modified version of the Motorica skeleton that is Z-up that packages with the plugin. So if we were to click import now, it would just import the source animations, but we want to do retargeting and other setup. So we're not going to click import, and instead we're going to click retarget. So now we have the option to click to select an IK retargeter, and I'm going to select the one that was packaged with the plugin. This is a Motorica to Mani IK retargeter that we've set up here. So what you can do is you can either set one up from Motorica to your skeleton or set one up from Mani to your skeleton and do 2 retarget passes. It's really up to you how you want to set this up. But we have this package with the plugin. And we also, of course, have the Mani mesh packaged with the plugin, so you can select the mesh you want to retarget to. Now we can add a suffix to the retargeted assets just to make sure that we can differentiate between the source and retargeted. And if I were to click import now, it would do the source import as we said before, but then it would do an extra step when it's going to retarget to your target skeleton. But we also want to do the setup for the post-search databases because we want to use motion matching. So I can click this button here, and now we've got a few more options. The first one is split into smaller PSDs. So with this unticked, we're going to create a post-search database for each gate. So we're going to create an idle one, a walking one, a running one, and a sprinting one. But if we have this ticked, then we're going to create one for each subcategory that we saw on the web app, or you see in your folder structure. So if we were using short paths, for example, you'd have a walk stops, a walk starts, a walk turns, a walk run database, all these different databases inside each gate. For long paths, it's slightly different. But we're going to keep this unticked because the gameplay setup that we have in here actually relies on a large database per gate. So we're just going to have that unticked. But it's an option there if you want to use it. Now we have an option here, which is add tags to created databases. This is purely for querying it at runtime in gameplay systems. So in the idle database, we'll have an idle tag. In the walking database, a walking tag. Running database, a run tag. And then inside transition databases like walk to sprint, we'll have a walk tag and a sprint tag. And what this allows us to do is it allows our animation blueprint to say, I want to know what gate I was in or could have been in. So I look at my animation database and then look at the tags inside and see, okay, this database contains walking and sprinting data. Therefore, I could have been walking or sprinting. That's the kind of logic behind it. And that is reflected in the animation blueprint. And that's how we use this data and use these tags. But we put the tags in there just in case you want to use them at runtime. You don't have to use them. You can use them if you want to. It's really up to you. And the next option here is the post-search schema. So this is the most important option. As you can see, without one of these selected, we won't be able to import. So I'm going to be able to select a schema here, and we have two options to package with the plugin. So we have the simple schema, which is one that just takes a couple things into account, like trajectory and the feet position, and also the pelvis direction. Just a very basic motion matching post-search schema there. But then we have the advanced option, and that is really based on, it's kind of heavily based on the Last of Us 2's motion matching system. They did a great talk at GDC, and we referenced that quite a lot while making this schema. We will link that in the description actually, so you can go and take a look for yourself. But we have that advanced schema that packages with the plugin. So you have the two options there. Now, the advanced schema does, of course, give better results. And honestly, the performance is very similar. We haven't noticed much difference between the two. So we would recommend using the advanced one by default. But of course, if you don't need all that data and you're making it for, let's say, some basic MPC, then you can use the simple schema and it will work just fine. So you have the options there. We're going to select advanced for this one. And now you can see this option, this button, sorry, has lit up because now we can import. So this last option is the normalization set mode. Now this is going to dictate what we do with normalization sets in the setup. There's three options here. First one is just don't create a normalization set at all. The second one is create one and add our databases to it. Or if you already have one, then you can use specified and select one that you have, and we'll add all the databases to that one. Now I'm going to use create new because we want a fresh norm set for all these post-search databases. And now the setup is complete. So I can click import, and you'll see the first process is importing the source animations. So this whole process, like I mentioned, takes just a few minutes. For a data set of this size, this is really the upper bound of size of data set that we export at Motorica, and this will take 3 to 4 minutes or so. So you can really go grab a coffee and come back. So I'm going to pause here, and we can fast forward to the part where we're going to start retargeting the animations as well. So now we're going to be retargeting, and this is going to be done in batches. So if you wanted to create the smaller post-search databases, as we had that option in the setup, this is where I'd be putting them into these specific databases. But because we chose one large database for all the assets in one gate, then we're just going to be doing that. But you can see it's doing it in segments, so we would be able to create the smaller databases if necessary. And this is the second part of the setup. And now we're done. So the quick import setup has completed, as this dialog says, which is great. So if we click OK, we're now going to be able to see the assets that we created in these folders. So there's three folders that are important here. The first folder is the source folder. So this is all the assets on our Motorica skeleton, as I mentioned earlier, and they are in the same categories that we saw before. So we can look at any of the animations, for example, run turns L variation 1. You'll notice it says variation 1 because I enabled phase shift on run turns L. So we have two variations of the animation, but you'll see it's just an animation on the Motorica skeleton with all the left turns in our database. And you'll see all the assets here are enabled, all the root motion settings, sorry, are enabled, so we can use this in post-search. Now, if we go back to the root folder of the assets that we created, so if we look into this folder, which is the retargeted folder, the second folder of importance, and we go into here and look at the same structure. So it's the same structure, categories and subcategories, and it has the same animations, but this time they're on the Mani skeleton instead of the Motorica skeleton. So we can go back, and I'll actually show you a different animation for this one, which is a loop, just to show you the fact that for looping animations, we also enable loop, so you don't have to do that yourself. It's all kind of automated for you. So that's set up, and now we have our assets from our database, but now on our target skeleton instead of the Motorica skeleton. So we can look at the final folder, the most interesting folder, the post-search folder. And if I click into this one, click the databases, you can see all the databases we have here. And we also have the normalization set. So I can look into the norm set, look into the databases, and you will see that in any of these databases, we have assets. I'll actually show you the database, the running database. So we can see all the assets directly in the engine, ready to go, just like that. So all our animations, and this is, for reference, 81 animations. This is just a subset of our data set. But you can see that we've gone from the concept of a character in Motion Factory at the start of episode 2 to the reality. We've got the character ready to drop straight into our gameplay system, all in a matter of less than half an hour, if we're including time waiting for animations to generate. That really is the speed of iteration with Motorica. And if you want to change the speed, change the turn rates or accelerations or whatever, you just go back, click a few more buttons, and we can bring them straight back into here just as quickly. It's really iterative and it's really fast. So for context, this is our sample project, and this is one that we aim to release at some point in the future, so you can use it as a reference for yourself. And inside here, we have a framework for assigning Motorica databases to characters to then use in the game that can be switched at runtime using this chooser system, and also retargeted at runtime using our runtime retargeting system. But I'll show you the asset association system, which is inside the choosers. So here we have two different chooser tables, and these are the high level chooser tables. This is going to be choosing which data sets are being picked from or being queried, sorry, at every frame. So these are the kind of the most important chooser tables in the project. And there's two variations, one that's designed to be used with our long path setup and one that's designed to be used with our short path setup. Now, because we generated a long path database earlier, we're going to go into the long paths chooser table. And here you can see this is our setup. There's a lot of different Booleans here that we dictate at runtime based on the user input and behavior. And you can see that we have proxy assets assigned to each one of these kind of cases or conditions. So I can go and show you where these proxy assets are referenced or even created. We'll go back, and inside here we have proxy assets. Inside long paths, you can see we have a proxy asset for each database. So we have one for idle, one for run, and then one for each gate pair transition. If we go back to the proxy tables, this is where we assign these. So you have your proxy assets, and that's kind of saying, this is a template. I will put an asset, a real asset here, but right now we're just saying this is a template and I want to pick an asset that is of this type at this time. Then for each character, we assign what that template will actually be. So for the male long path character here we have in the project, this is just the default male style. Then we have the same databases, but instead for the soldier combat style, and we have those assigned. So for each different style, we have different post-search databases, but they all use the same proxy assets. So we can use one gameplay system and live switch assets in and out whenever we want to. So for this, I'm going to create a new proxy table for our character. And to do that, I will go into miscellaneous proxy table. I'll call it PXT PSD, that's proxy table for post-search databases, male, or we'll call this tutorial dataset just to differentiate, but it was with the male normal style. So tutorial dataset. So we go into here, and now we need to assign our assets. So I'm going to add a row, add an asset, and say that the proxy asset for long paths idle is going to be inside tutorial datasets. We can now filter and find our datasets that we just created. Is going to be this idle. And then I create another asset. This one is going to be proxy asset for the run. And I'll say that's my run one. And I'm going to do this quickly. I'll just speed through the setup, but I'll do this for all the different proxy assets. So here you can see we've assigned our actual assets to our proxy assets. So our proxy table knows which assets to be querying. But there's still some setup to be done before we can get the animations going in game. And the first thing to do is actually do some post-processing on the animations themselves using some animation modifiers. And that's because we use orientation warping and foot locking just as a way to kind of increase the amount of coverage procedurally within limits that make sense in the animation blueprint. And these are techniques you might have seen in other projects such as Gameplay Animation Sample Project. But we can go in here and actually look at the animation blueprints we have. Well, sorry, the animation modifiers that we have. So inside blueprint, we have anim modifiers, and we can see we have one for foot speed left, one for foot speed right, and one for orientation warping. So I'm going to go and find the assets that we just imported, and we'll go for the retargeted assets this time. I'm going to go to the root folder, filter by animation sequence to get all of our animation sequences selected, right click, animation modifiers, add modifiers, and we'll add all of these. So foot speed left, foot speed R, and orientation warping alpha with the default settings. And these were taken from the Gameplay Animation Sample Project, so you can just take them directly from there, click apply, and it does take a little second to do, so we'll wait for that. So now we can see that the assets have been modified. So if you go into one of the animations, we've got the curves now. We've got the foot speed left, foot speed right, and orientation warping enable. And what this is going to do is it's going to give more information, or the information that these nodes actually need inside our animation blueprint so they can do foot locking and orientation warping. Now, you can disable both of these features in the animation blueprint, not use them at all. It's really up to you. It's just techniques that we use to improve the quality of the locomotion system. But the next thing we need to do is assign the assets to our character. So I'm going to go into the third person character blueprint we have here, and I'm going to go into class defaults, and then I can search proxy. This is a setup we have for the long paths and short paths. If you wanted to have them both loaded at the same time and do some comparisons for performance testing, whatever it may be. But I'm going to search tutorial dataset, the one that we just created, and put that into long paths. Hit compile. And now the job is almost done, but not quite, because we have to go into the animation blueprint now. So we can click mesh and search to the animation blueprint. In the anim graph, you'll see that to make the character T-pose and slide around to show you what we had earlier, I disconnected these nodes. So we can reconnect these nodes, click compile, and now we have our system ready and going. We can head back, click play, and you'll see that we now have our character motion matched in the scene and ready to go. And this is with the animations that we just imported. So the setup, just to kind of go over the steps, was first, generate your animations in Motion Factory, then use our plugin to import those animations, then assign the assets in the way they need to be done, do any animation modifiers you need to do for the post-processing for your animation system, and then we're ready to go in gameplay straight away. Now, I didn't go over the animation blueprint setup because that is quite complex and will take some time. Also, we are planning on releasing this at some point in the future, but I can quickly go over it to a high level. So what we have here is our motion matching node. That's where the poses are selected. This setup here is doing some orientation warping and some steering inside this motion matching node. Then once that's done, we feed that into the pose history. So now we have the pose history recorded with the trajectory node. That's generated in the thread safe update animation function, which I'll go over in a second. But after that, we head into the offset root bone function, and that's where you'll see this information here. Green is where the mesh is, and blue is where the capsule is. So we're always kind of trying to pull the mesh towards the capsule, but we're giving it some freedom to come out of the capsule's bounds a little bit, just to make the animations look a bit more natural and prevent artifacts such as foot sliding and other things like that. But yeah, we've got that set up. And this uses some logic that we have inside the thread safe update function as well to decide which translation mode and rotation mode to use. Once that's done, we then pass that through a leg IK layer. And this is going to do some foot placement, as we mentioned before, and also the leg IK. So you'll see when we go on a slope, we have the IK working like that. So it's not just penetrating the ground. We have the leg IK set up there. And then that's the output pose for that layer. Once that's done, we then do some hand correction to get the hand pose on, because currently outside of Motorica, we output a static hand pose, and we want a little bit of motion on the hands so we can put an unarmed jog forward hand pose. This is also where you do some hand posing for if you're holding a gun or you are holding a sword. I'll go over that in the retargeting episode, which is next. But yeah, we have some different hand pose options there, and we have a setup for that. But we'll skip over that. Here are some to-do notes that I left for myself because this project is still under construction. So this is not finished. We've got some things that we want to do here to make it a little bit better. And the output pose is there. So first, we're checking that everything is valid inside here, the references. Then we go and update the trajectory. So we have the trajectory to push into pose search. And the way that we get this is via this predictor function, which is it's a function that uses an interface in our spring movement component. Then we store some variables that we need for future. After that, we then update essential values. This is stuff like speed, acceleration, just stuff that we need to know about the character's motion and the user's input intentions, so also input directions, so we can have a bit more context and pick better databases and filter down the amount of data that we need to search through each frame. Then we're going to update the character state. This is more of that, but this is separately. So this is kind of just doing very categorical data like enums and booleans to work out what is the character state at this frame, so we can pick the right things for that. Then it's root offset update. So this is stuff. So this function is where we select things like the translation mode and the half-lives to use on the root offset bone based on user input. There's a lot of things going on here, as you can see, but they're all kind of factoring into a final decision of what are we doing with the root offset bone node at this time, at this frame. And then we have a system which allows us to detect if there's a gait transition happening. So if we're going from, say, walking to running, this Boolean will be true. And then we're going to update some things like how long is remaining. And we use those tags that I mentioned earlier before in the setup to detect where we're going to and from, so we can pick the right database for that as well. So that's the whole thread safe update function, and it happens thread safe. So you'll see in the event graph, we actually have no logic. Well, okay, it's not connected, but this is just some print stuff that I added before for debugging. And this is on the initialization. So there's no game thread stuff happening in this animation blueprint, in the blueprint itself, in the event graph, which is great. Love that for performance, especially when we have about 100 of these characters running around in the same scene. This is really important. So we've gone from the idea of a character at the start of episode 2 to a fully animated character inside the engine by the end of episode 3. And that whole process took, give or take, 30 minutes while including time waiting for animations. And you can see this character is walking, running, strafing, moving quite dynamically. It can stop, can turn in place, all these different things. And it can also sprint. But yeah, that's the character. Now, you may be thinking, we have the character here. How do I get this onto my character? Well, there's two ways. You could either do the retargeting via the plugin that I showed earlier, and instead of retargeting to Manny, you would retarget to your skeleton. Or in the next episode, I'll be showing you a runtime retargeting setup that we have, which allows you to use the same setup without retargeting a base. It's a lot more flexible if you're using it on different characters or you're just in the prototype phase, and that will all be documented in the next episode. So that's it for this episode. Don't forget to subscribe to the channel so you don't miss out the next episode. And that'll be the last episode of the series where, like I said, we'll be going over retargeting and just some final notes on the series, and also how you can get the data set that we used in this series to try it out for yourself. So stay tuned and I'll see you next time. Cheers.